Hello, Mr. Area, alright?
Yeah.
Okay. So today we're going to talk about the multiples of 3 and 7. Okay, what does it mean? For example, like if I give you a number 13, and then you can choose any number of multiple of 3 and plus any number of multiple 7. So basically we want to looking for 3a plus
3 plus 6.
7b.
No, 7 plus 6. 7 plus 6. 1 times 6.
Yeah, exactly. So these a and b
Easy peasy.
are non-negative.
Non-negative.
Okay, to add non-negative. So you can choose 0, 1, 2, 3, okay? So you need to tell me if it's possible or not, okay? If it's possible or not. So another example like 8. Can you do it with 8? No, right? That's right. So you tell me it's false. How about 9? Is it okay? 3 times 3, yeah?
Yeah.
But you don't need b will be 0, okay?
Is
So you got
8
it.
times 7.
Okay, so how can we do it?
If it's in the 7 times tables.
Or 3 times table, yeah, and okay.
3 times tables.
Okay, how about the mix? Like 10.
You
That's
would
pretty obvious, 10.
3 and 7.
Yeah, you see? So either in 3 times table or 7 times table or the mix. So how do we check the mix? Yeah, how are we checking it? So any idea? Any idea?
Oh, if it's in the 10 times tables, it's possible.
But it's not necessarily the 10 times table, yes. Yes, you're right, in 20, yes, of course, yeah, because I got 3 and 7 and I can just times multiple, yeah, 1, 2, 3 for each. But how about like the 13? 13 is 7 plus 3 times 2, right? Yeah, so that's 1, that's 2. Any idea?
This might not work, but
What?
but I think it's trying to do as much 7s as we can.
Yes. Well, or try doing as 7 as we can.
As many 7s, and then when we can't do another thing, we do some swings.
Okay.
It might not work.
It might not work. Okay. So wait.
Wait, let me find an example.
Yeah. So we want to find the number of. So we want to find the multiple of 3, and if
I know.
Yeah.
Example.
Yeah.
I know example.
Okay.
Example of 16.
Yeah.
You can. If answers 7, 3, 3, 3, right?
Yes.
And you can't do as many 7s as you can. Because
Okay. So what's your approach to do this? If given a very big number, what's your approach?
Such as.
I don't know. 100. Can you tell me 100? It's hard, right?
7 tens and 3 tens. Easy peasy.
Yeah.
Even
You are.
10 times 10.
Okay.
Do a harder one.
I don't know. Okay, so
Do like something like yeah.
look. No, let me just write a recursion, right? We can check it recursively. You tell me. Look, Eric, Fn. If n is smaller than 0, we return what?
Kick.
Yeah? Return what?
So return nothing.
Return false, right? We count, right? Okay? If n modulo 3 equals 0, return what?
True.
If n modulo 7 equals 0, return what?
True.
Okay. Okay, so then you tell me what to do next, okay?
And blah blah blah. Blah
So the number,
Whoa.
the number. So okay, so what happened to the number? So return what?
Something.
N. Okay, we are working on this n. So what's the purpose? So if any of these, n minus 3 and n minus 7, is a number, a multiple of 3 and 7, then this number must be a multiple of 3 and 7. Am I right? Alright? Yeah? Yeah? Look, we don't know, right, Eric? We don't know this n. But if this number, Eric, if its number is true, or if this number n minus 7 is true, then this number is also true. Am I right? So what? If f n minus 3, what? F n minus 7. So what to do? What to do here? Come on. Come on.
We should.
Wow. Top down. Remember, top down. Top down. Dynamic programming, top down. We are working on this number case n. Listen to me, Ari. You're losing focus. If we are working on number n, but if we know fn minus 3 or fn minus 7, if any of them is true, then this must be true. Am I right? Yeah?
Oh yeah.
Yeah, so what should I put here?
Plus.
This is a true-false question. If this is true or this is true, so what should I put here? Oh, come on. Does it make sense, Eric?
Return true.
That's it. Return this or this. Got it? Eric?
Okay.
What's missing here? Do you remember?
Dash.
Yeah, cash. Eric, listen up. Dynamic programming, yeah? Dynamic programming, yeah? Look, if n minus 7, then what's this? N minus 6. N minus 3 minus 7, right? And then what's that? What's this? N minus 7 minus 3. And n minus, look, 7 minus 7. So look, yeah? Duplicate calculation. N minus 3.
In different places.
But this is the same value. It calculates different. So we need a cache, right? As long as we need.
The explanation.
Yeah. What's the time complexity for this one? What's the time complexity? Come on. Stop saying that. Over.
N.
Over. Yeah. What's the space
I literally
complexity?
just said then.
What's the space complexity?
Over 1.
We're using cache. Come on.
Okay, fine.
Okay, fine. Okay. This makes sense, Eric.
Okay.
Can I have it?
Okay.
What is this approach called?
Top down.
Dynamic programming, yeah?
Yeah.
Yeah, top-down dynamic programming. How about if we just going through the number of multiples? Very good. Define Fn. Look, if we're going for I in range, let's say I is the multiple of 3, okay? Yeah? Multiple of 3. So you will go to n divided by 3 plus 1, right? That's the maximum you can get, right? If n minus 3 times I, right? If we are proof of the I in the multiple of 3, if it can be modeled by what?
If it can be the modulus 3.
I is the multiple of 3. If I minus multiple of 3, I can modulo by what?
7.
7, yeah. Then return
True. Return false.
Okay, that's it. What's the time complexity?
O. N.
What's the space complexity?
O. 1.
Wait down. We can write this, turning this into y none, yeah? So we can just say return what? Any. Any means any of these is true.
Any.
Any what? N minus 3 times I modulus 7 what? Equal 0. For what?
I in range n divided by 3 plus 1.
Yeah, basically just copying, just arrange this into this. Right? If these return true, then we can say any of these we are looking for any I, any this expression is true for I in like that, yeah? Correct? Okay.
Bruh.
Okay, so all yours, can you write it?
At least
Define.
one.
Fn, okay? Yeah.
Can I pick anyone?
Anyone. That's your task today. Come on, I give you two. You can.
I'll do the first one.
Okay, let's easy. First one. If what?
If
Yeah, if what?
n smaller
Yeah, then zero.
return
Yeah.
false.
False. Capital F. Yeah.
If
If if it's more.
N.
Yeah.
modulus
Yeah.
3 equal 0.
Or you can put an or here. Or modulo 7. Yeah. You can write it in the same.
Or
Yeah. Yeah.
n modulus 7 equals 0.
Yeah. Return. Return what?
Return true.
Yes. And what?
Return
And yeah, return what?
return
Return what? We call it. Yeah, we call it itself. Yeah.
f
Yeah.
n minus 3
Yeah.
or f n minus 7. Right.
What's the term complexity for this one? You're missing something.
Oh yeah.
Okay, so can you explain to me what's this?
Cash.
Can you explain to me what's return fn minus 3 or fn minus 7?
That is fn minus 3 and or return fn minus 3 or fn minus 7 means that basically that thingy. I mean, wait. What
So
is
can you give an example, like 16, for example?
16?
Yeah. What?
16 is the n.
Yeah, and it's
And-
16.
And is 16. And if we know f 16 minus 3
Yeah.
and f no, f 16 minus 7 and f 16 minus what? Wait, what was it again? 6? Yeah. Yep. And 16 minus 7. No, yeah, wait, no, yeah, oh yeah. Yeah.
Minus 10, right? If you minus 3 minus 7, that would be minus 10.
Here,
The right, on the right.
here.
Yeah.
And it's supposed to be 7.
So you go to the left, that would be minus 3. Go to the right, that would be minus 7. Yeah? You already minus 3, and then you go to the left, it would be minus 6. That's correct. If you minus 3 and go to the right, that would be minus 3 minus 7. That would be minus 10, right?
Okay, minus 10.
So if you look at the right note, f16 minus 7, that's f9, right? And we obviously, the 9 can be represented by 3 times 3. So what does it mean?
We can do it by dynamic programming thingy. So we can
Yeah. And the cache is to avoid duplicate numbers, yes? Because we know f9, we can 3 times 3. And then any number, if n minus 3 can be represented, right? Using the multiple 3 and 7, then this n must be represented by multiple 3 and 7, yeah? Either of these, that's why we said or, right? Am I right? Got it?
Or.
Yeah? Okay, let's see, what's the time complexity?
Does it? Oh, and space comes down because the only one. Bye.
Oh, and.
Oh, and bye.